Okay, good morning, everyone. Okay, um, before we get started, do you have any question? Okay, so if you have no question, we're gonna talk about simple linear regression today. So we're gonna jump to the chapter 10 first. Then when we come back when we finish chapter 10, we're gonna move on to chapter 7 and 8. That will be end of the semester, right? So we finish the entire curriculum. Okay, so chapter 10 is on a simple linear regression. And this is very useful topic and has a lot of important applications, in different fields, also in your life. Simple linear regression. It's also called regression analysis. So mainly deal with two topic: correlation and then regression. So basically, we have two parties involved in this particular analysis. Okay. One party is called the independent variable. The other one is called dependent variable. Just like any algebra course, right? You have two variables versus dependent variable. So we basically just try to using the independent variable. Use the independent variable to make prediction about the dependent variable. Predict the dependent variable. Once we figure out their relationship, right, and using some index, then we get through those index shortly. So basically, by understanding the relationship between these two variables, and we'll be able to come up with a model, right? We call this simple linear regression model, and we use the model to make prediction about the dependent variable. And the model itself looks very straightforward. We're using this. It's basically a linear model. Y hat equal to B0 plus B1 times X. Here, Y hat representing predicted Y values. Y value here is independent variable, right? So independent variable we always use Y. No, dependent variable always use Y. Independent variable is always X. Okay, and then X here obviously representing the X value, right? Called the independent variable. And B0 representing the slope. No, the y-intercept. Okay. And B1 is what we call the slope, right? So basically it's a linear model. So we're using a linear model to understand the relationship between those two variables. All right, so now basically the first impression is when you look at, let's say, for example, let me give you a data set, right? Let's say we have a data set. In this data set, we have two variables, okay, X and Y variables, and I'm putting as order pair, right? Let's say 2, 5, 3, 6, 5, 7, and then we have 4, maybe 8, and 8 will be 12. Okay, something like that. So in order to understand the relationship between these two variables, we use a visualized tools, right, called scatter plot. So when we do the analysis here, we start with the scatter plot, meaning we just plot this, right, and then put in the, so basically this is all the pairs 2, 5, 3, 6, 5, 7, 4, 8, 8, 12, right? Just like any algebra course you've been dealing with, we just basically put in the order pair and then plot it. So x variable goes here, right? X is what we call independent variable. And then y variable goes here, okay, dependent variable. And we're gonna plot those order pairs first and try to understand what kind of model fits here. Let's start with 2, 5. Right? So look at the x values. The maximum is 8. So only need 8 units here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now on the y value side, and the maximum is 12. So it will be 2, 4, 6, 8, 10, and 12. We start plotting this. So 2, 5, that's first order pair, goes here. 5 is right in the middle, right? So it's here. So 2, 5, that's first order pair, make it solid point. 3, 6, 3, 6, a little above it, right? And 5, 7, 7 is right in the middle of those. Okay. 5 and 7 goes here. And we have a 4, 8, 4, 8. Okay. And then the last order pair is A, 12. All right, here we go. So if you look at this, scatter plot, and then let me use a different color so you can see the comparison here. Okay. See this color. Okay. And if you look at it, just by looking at the scatter plot, when x value increases, right? It looks like the y value increases. So x increases, then y increases. Look like that way, right? And then basically, if you look at it, we can fit a model here. And this is the whole purpose, right? We will try to fit a linear model here to understand the relationship between these two variables. And according to the graph, we know that x increases and then y increases. We call this direct relationship or positive, right? Meaning they both move in the same direction. That's what they call a direct and positive relationship. So scatter plot is one of the most important tool, right? We use to understand the relationship between those two variables. Now let me give you another example, right? So let's say we look at another data set. Again, I'm just making up this data set and then help you understand this. Let's say 3, then it's 12, 4 is 15, and 8 becomes 6, then 6 becomes 3, and 5, that gives us, let's say, 8, something like that. Okay, so this is another data set. And in this data set, we have some order pairs, and then let's see how we will understand this. Let me just change the color really quickly. Change back to the. Okay. All right, now again, we're gonna construct a scatter plot, right? Try to understand this. So we start with the scatter plot. Okay. So again, we turn into order pairs. So first one is 3, 12. Second one is 4, 15. Then it's A6. Then 6, 3. Then 5, 8. And that's 5 order pairs as well. So right here, let's put into the scatter plot. So again, x goes here, y goes here. We have two variables. Then look at X values. The minimum is 3, maximum is 8. So again, we only need A units. 1, 2, 3, 4, 5, 6, 7, 8. On the Y value side, right? So you have a maximum is 15, minimum is 3. So let's say we do this. We do again go up by 2 units. So 2, 4, 6, 8, 10, 12, 14, and 16. The maximum is 16. That should be enough. 8, 6, 4, and 2. Okay, then we start plotting this. So 3, 12 goes here. First order pair. Now 4, 15. 4, 15 goes here. Then we have a A6. A corresponds with 6. Okay. And 6, 3. 3 is right here. 6, 3 goes here. Now the last order pair is 5, 8. Here you go. All right, so now if you look at these 5 order pairs, looks like when X increases, right, the tendency here is when X increases, look like the Y value decreases, right? So X increases, it goes this way, this direction. X increases, then the Y value goes down, so Y decreases. They go hand in hand, right? So that means this is what we call indirect or negative relationship. So those are two common scatter plot you will encounter, right? Either they are direct relationship or indirect relationship. And once you present a graph, you'll be able to see this fairly clearly. But sometimes you may come up with a scatter plot, right? Which is random. That's also very possible. And so you have some scatter plot look like this. So you have data set, and then when you plot it, it look like random plot. So this kind of random plot, random scatter plot, tells us there's no relationship. There's no relationship between those two variables, X variable and the Y variable. Between those two variables. Okay. All right, so far, do you have any question about this, the scatter plot? And this is the first step. We usually start our analysis. Okay. And now let's take a look at how we come up with the, let's measure the strength of the relationship, right? So when you compare these two, I would say that the first graph has fairly stronger relationship because when we try to fit a linear model here, those points are closer to this model here, right? Our best fitting line, we call this best fitting line. And if you look at the second graph, actually they are further away, right? All those points are slightly further away. So this tells us the first graph, the first data set has stronger relationship, meaning they have stronger correlation between those two variables. And how do we make determination of that? So we use this particular statistics we call correlation coefficient R. Okay. Coefficient. So this is the index we are utilize to determine the strength. Determines the strength and the direction of the relationship. So if R is positive, right, then we know that it's positive relationship or direct relationship. If R is negative, then that's negative relationship or negative correlation, indirect correlation between those two. And then also R has benchmark, right? So if absolute value of R is greater than 0, less than 0.25, then we call this weak correlation. If R absolute value of R is greater than equal to 0.25, but less than 0.75, we call this median correlation. And if R is absolute value of R is greater equal to 0.75 and less than 1, and this is strong. Correlation. If R equal to 1, right, absolute value of R equal to 1, then we have perfect correlation, meaning it's perfect relationship, and it's very difficult to find in the real life, the real world, perfect correlation. So the sign of R determines the direction, right? Direction of the relationship, and then the value of the R, absolute value of the R determines the strength of the correlation. And we're gonna perform a full analysis on this. Maybe not just use the first data set we created, right? Since we already use it. So I'm gonna, let me see if I can copy this. And let's take a look at how we come up with the R. So basically that's a very lengthy, formula, but actually when we follow it closely, it should be good, right? So let's see. And you can find all the formula in the formula sheet. Okay. Let me point out all the formulas we need for this particular chapter. So go to Blackboard, open the formula sheet. If you go to chapter 10, linear correlation regression formulas, one of the most important formula is R, right? This is one of the important things. R formula. We also need B1 formula and B0 formula. And this is regression model, right? We're talking about. Once you know B0, B1, then we basically come up with a regression model to understand the relationship between those two variables, but which usually start with the R to help us understand the strength and the direction of the relationship. So now let's start with the calculation part, right? So in this formula, we need several things. We need to sum up all the X values. This symbol here, it means sum up all the X values. The second one, summation of Y, means sum up all the Y values. Then we also need to sum up the product of X, Y, right? We also need to sum up the X square. We also need to sum up the Y square. And basically we need 5 things, right? We need to sum up 5 things. Summation X, summation Y, summation X square, summation Y square, and summation XY. And once we know the sample size here is, we have 5 ordered pairs, so sample size is 5. So now we know the formula we are using, so let's go back. Okay, so right here, we're gonna do the prep work first by creating a table, and let's continue the table. We need to find 3 more things. Okay, let me extend the table. Then we need X times Y, right? And we also need X squared, then Y squared. Okay. Now, first of all, let's complete the table. Okay, so XY meaning X times Y. Okay, so we multiply those, get 10. 3 times 6, you get 18. 5 times 7, that's 35. 4 times 8 is 32. And 8 times 12, that's 96. Okay. Now you square all the x values, right? X squared means square 2, you get 4. Square 3, you get 9. Square 5, you get 25. Square 4, you get 16. Square 6, square 8, you get 64. Okay. Now we're going to square all the y values. So 5 squared give us 25. 6 squared 36. 7 squared is 49. 8 squared is 64. And last one is 12 squared is 144. Okay. And now once we have all of this calculated, now meaning next step, we're going to sum up the x values, right? So adding all these up, we're going to come up with a summation of x here. Right? So sum up 2, 3, 5, you get 10. Adding 4, 14, adding 8, 22. Okay, now you sum up all the y values. That means 5 plus 6, 11, adding 8, adding 7, 18. 18 plus 8, 26, 26 adding 12, 38. Okay, now again, we're gonna sum up each one of these, but I'm gonna show you how to do this in Excel really quickly. Okay, and let's get a number in Excel. Okay, so this is important starting point, and once we have all this ready, then we're able to R and the rest of them. Okay, so let me do the data entry really quickly. So the x value goes here, y value goes here. 2, 3, 5, 4, and 8. And second one should be 5, 6, 7, 8, and 12. Okay. Now I'm gonna share the screen with you. Okay, so we have these two, and then we need some more, right? We need 3 more columns. Now let's format it really quickly, bold it, center that, put in our borders. Then we're good. Now let me maybe make it slightly bigger. Okay, 15, 16 is good. Okay, so now this is total, right? So we need to sum up several things. We sum up x. We did it by hand first, right? 22, that's good. Sum up the y, we get 38. And we need xy, x times y. Okay, so you multiply 2 by 5. Then if you do one of them, we can get the rest of them down in Excel, and let's get a total, right, for that one. Okay, 191. And now we need x squared. Okay, so square the x. Get that. And once you do one of them, now again, we drag it all the way to the bottom, get the rest of them. Now we get the total of x squared, and then y squared, very similar, square the y value, get the first one, and we could drag it to get the rest of them. Okay, and one more time, sum up the rest of them. Any questions? Am I going too fast on the table part? I can repeat that if you feel like you're getting lost. Okay. All right, so now the prep work is done, right? So that means we have all these numbers ready. Then go back a little bit. Let's just transfer these numbers here, okay, to what we have here. So summation xy, 191, 118, 318. So go back here. All right, so we get summation xy from the Excel and that's 191. You can also just put into the calculator, get this number, will be the same, right? Summation x squared is 118, and summation of y squared, total of all the y squared, and that turned out to be 381. Let me quickly double check. 318. Okay. All right, so now we complete the prep work. So next thing is applying the formula. Okay. So the formula is R equal to n times summation of xy, total of xy. I just copy the formula from the formula sheet, right? You can also do that. Summation xy minus summation x times summation y. Okay, that will take a numerator, and denominator is n times summation x squared minus summation x parentheses square multiplied by another square root n times summation y squared minus summation y squared. Now all we have to do is just plug in all the given number, and then if you look at, we have 5 order pair here, so n is equal to 5. Okay. You count how many x values, right? We have 5 x values. That means we have a sample size of 5. So now n becomes 5. Now summation xy, we match it here, right here, 191. 5 times 191 minus summation x is 22. Summation y is 38. Okay. That take a numerator. For denominator is the square root 5 times summation x squared is 118 minus summation x is 22 squared, and multiplied by another square root. If you want to put this in the parentheses, that's fine. And n sample size 5 times summation y squared 318 and minus summation y 38 squared. Again, we can put into parentheses now, and let's get the Excel do the work for us. Okay, we'll go back here. So we need to calculate the R. Okay. Well, let's lay down what we'll try to calculate, right? So we try to calculate correlation. The font size is too big. Okay, continue. Correlation coefficient. And we use the symbol R to represent that. In this case, R is equal to, and let's put it, let's do it here. Okay, and we just follow all the calculation we have there, right? So put equal sign first and put numerator in parentheses. So we have 5 times summation xy 191. If we go up a little bit, be able to see all of that. Okay, summation xy 191 minus summation x is 22 times 38. Okay, that will take a numerator and divide by denominator. We have a big parentheses and then first square root.
Sorry, do you mind just slowing down a little bit?
Okay, sure. I can slow down a little bit. Okay, so again, you all start from the formula, right? And then we just try to transfer all of these numbers into the Excel and then get a result. Or you can put it into the calculator, right? Calculator will have a very similar input. But before we can do that, we need to come up with all these different total, right? Each total for each column. This is a very important step. And make sure you have the right number, because if any one of these numbers is off, then this outcome will be totally off. Okay, so just pay attention, double check the numbers in the table. That's a very important step. Okay, now let's go back here. So for numerator, we have a sample size 5 times total of xy, right? Total of the product of xy, it's 191, minus total of x times total of y. So 22 times 38. And divide by the denominator, we put in a parentheses. So open parentheses, square root. First one will be sample size against 5 times summation x squared, total of x squared is 118. Okay, and minus total of x squared, 22 squared. All right, and then we'll take care of the first square root, the second square root times sqrt, sample size 5 times total of y squared, so 318, and minus total of y, 38 squared. Okay, and then we close the denominator. Then we should be able to get this, right? Get this, the result. Okay, and typically you run it to 4 decimal places. It's already running to 4 decimal places, so we good, right? So it's 0.9566. Okay, so let's go back a little bit. 0.9566. That's the result we have. 0.9566. So based on this value here, first of all, it's positive, indicating it's positive correlation or direct relationship between these two variables. Secondly, it's bigger than 0.75. It's in this interval here, right? Absolute value of the R is greater or equal to 0.75, less than 1. So that means we have a very strong correlation here. So the summary here is it's positive, strong correlation. Just by looking at this value, we come up with this conclusion. Positive, strong correlation. Okay. So this is what R gives us, right? And that's what we come up with from this part of analysis. So this is all computational, but it's very simple calculation, right? It's not that complicated in terms of completing the table. The formula, in terms of applying the R formula, you just need to be careful about the radicals, right? Square root, that's all. And once you have the value, we'll be able to determine that, this direction and strength of the correlation.
So if it was a negative, do you just make all of the correlation numbers negative numbers and figure out which segment it applies to in there?
You mean,
like say it was negative 0.9566.
okay.
Then how would you find the correlation of it?
Oh, so that would be, if it is negative 0.956, that would be negative strong correlation. So for example, right, if your R come out to be negative 0.9566, right? And that will be negative or indirect, right? Negative. Also indirect strong correlation. Still strong, right? But it's on the opposite side, meaning when X increases, then Y decreases. Actually, matter of fact, we're gonna look at the second case, which is this case. You'll be able to see that. We're gonna also analyze this one in a bit. But yeah, according to this particular data set, it will be a positive strong correlation. But yeah, definitely, you may encounter negative R values, very possible. And we just come up with the conclusion accordingly, right? Based on the value itself. Does that make sense?
Yeah, thank you so much.
Okay, no worry. All right, and let me just continue this. And let's get to the other part, B0, B1, right? So think about it. We know the strength and direction of the correlation. Our next step, let's figure out what is best. Let's find out this best fit line, meaning the regression model here, that will represent this relationship. So in order to do that, we need to find out a couple of things. We need to know B0, also B1. And we also have a formula to follow, right? B0 is this formula. Again, it's quite, the formula is quite long, but it's not that complicated. B0 and B1 formula. Once we calculate that, you see all these elements, it's ready, right? Once you complete the table, all these elements are there. We can just extract it, plug into the formula, and get B0, B1. Okay. So now let's move on to how to find out B0, B1. Okay. So start with the B0. Again, switch back to the note. Now we still stick with the same example, right? So now let's calculate B0. Okay. So that's right out of B0 formula. Okay. Just copy that from the formula sheet. So it's a total summation of y times summation x squared minus summation x times summation xy. Okay, that would take a numerator, denominator are the same for both formulas, n times summation x squared minus summation x parentheses squared. All right, so now again, all these numbers are there, right? Just pick it and plug into the formula. Total of y, 38. Total of x squared, that's 118. Total of x, 22. Total of xy, that's 191. Okay, then we divide by sample size, again, is 5. We have 5 order pairs. Summation of x squared is, again, it's 118, and minus summation x, total of x is 22, and square that. Okay, so now one more time, we're going to use Excel to do this, and then we're going to run into 2 decimal place. Go back to the Excel. Now, second thing, let's find out B0. Okay. Then numerator, total y, 38, right? Times total of x squared, that's 118, minus total of x, 22, times total of xy is 191. Okay, that would take a numerator, and dividing by denominator is sample size 5 times total of x squared is 118 minus total of x squared, 22 squared. Okay. Then once you put in the number correctly, then we should get a result. Okay. So this result turned out to be 2.66. So probably make it a slightly bigger, same size as the other ones. Okay. Then we run down to 2.
I'm just clicking on it one more time.
Ah, sure thing. Okay, here you go.
Thank you.
All right. So that's B0. 2.66 once you hit enter. Now let's go back here. So we get a result of for B0, 2.66. Then let's take a look at B1, right? Put it just side by side. So B1 is n sample size times summation of xy minus summation x times summation y, and dividing by denominator are the same for both calculation here. Summation x squared minus summation x minus c squared. Then again, we're gonna copy the number from this, right? From this prep work. So sample size is 5 times total of xy, that's 191, minus total x is 22, total of y is 38. Have all of that. And that's numerator, denominator. We have 5 order pairs times total of x squared is 118 minus total of x 22. Square that as well, right? Now again, one more time, you can put into the calculator or Excel to get a result. Since we using Excel, so let's stick with the Excel here. Okay, so B1. So 5 times total of xy, 191. Okay, minus total of x times total of y. So 22 times 38. Okay, that will take care of the numerator. Divided by denominator will be simple size 5 times total of x squared, that's 118, right? Minus, okay, minus total of x squared. Okay, here we go. One more time, give you 1 minute to look at what we have here. Exact same thing from the handwritten note. Okay. Once you have that ready, hit enter. So we get 1.12. Okay, let's shrink down a little bit to 2 decimal, just keep it consistent. So that means B1 is 1.12. Go back here, so B1 turned out to be 1.12. Now that tells us we have the regression model ready. Meaning, so this simple linear regression model to represent this relationship is predicted y value. Think about it, why it's predicted y value, not actual y value, right? Why this is called predicted? Okay, and B0 plus B1 times x, right? So we have B0, we have B1. Now just throw in both numbers into the model, so you get a regression model here. Simple linear regression model, simple linear regression. It's an abbreviation of SLR, means simple linear regression model. And B0 is 2.66 plus B1 is 1.12 x. Okay, so we come up with a regression model. So that's another important part of the analysis. It's quite important. Remember, we're talking about making prediction about a independent variable part. So now think about this. Let's say, assuming, remember, in our original data set, we have a data value 2, 3, 4, 5, 4, 8, right? That's assuming if x equal to 5, and what will be the predicted y value? So all we have to do is replacing x here with 5, right? And let's find out the predicted y value. So 2.66 plus 1.12 multiplied by 5. And let's see what that is. Again, let's use Excel to do all the work. So next thing is what if x equal to 5? Then what happens? Then we're gonna do 2.66 plus 1.12 multiplied by 5. Okay, and this is what we call the predicted y value, and it's 8.26. Think about it. In our original data set, right? When x equal to 5, we're supposed to have the actual y value 7. However, using this model, using this regression model, we get a predicted y value, which turned out to be 8.26. And so again, model does not capture all the points on the line. Think about this. We try to fit a regression model here. None of these points is on the line, right? That means your predicted value will be different from your actual y values. So that sort of makes sense because regression model is what we call the best fitting line. It's best possible line we can come up with to capture the relationship. Again, it's not perfect line. That's why it doesn't go through all the points, all the given points in the data set. That is why it's called predicted y values. Now, more important thing is, think about this. In our data set, right, we do not have the value for 10, right? Let's say x equal to 10. What happened when x equal to 10? We don't know that. However, when we have this model now, we can make prediction about that, about unknown variables, right? When x equal to 10 now, then the predicted y value, according to the model, should be 2.66 plus 1.12 times 10. So this is 2.66 plus 11.2, and this turned out to be 13.86. So the useful feature of this regression model is to try to predict the y values for some unknown x values, right? Because x equal to 10 is not available here. So you wouldn't know what happened when x equal to 10 or 9, right? Or 6 or 7, right? It's not here. However, by utilizing this model, we can make a prediction about that. So that's how we utilize this particular regression model to make prediction about the dependent variable, which is very useful feature. And think about it. Let's just give you example, right? In the stock market, let's say if you can use a historical data, right? Let's say that the stock price from yesterday, you can come up with a prediction about the stock price in the tomorrow, right? Let's say or next moment, and if you make a very good prediction, then you'll be able to make profit out of it, right? You can make profit on the market. That's what those Wall Street analysts, obviously they use much more complicated models, right? This is just simple linear regression model, and it's like very entry level. You know, you can encounter. If you want to learn more, you can study MA 321. You'll be able to learn a much more sophisticated model used to make prediction about the anything in real life, basically, right? As long as you can come up with a model, then you can utilize that. Okay, so now, any question about this, about making prediction part? So this is predict unknown x values. Okay, so now, how do we come up with the best fitting line? We basically just put these two into the order pair, so 5, 8.26, and 10, 13.86, right? So now, when we already have a scatter plot, and we just have to plot those 2 points. Let's say 5 here, 5 is 8.30 something. So this first point here, let me use different color, so we could come up with best fitting line on the scatter plot as well. Let me use a bright color. Okay, 5, 8.20, 8.30, 26, something like that. So it's somewhere here. Okay, so this is first point, and then we also have 10. 10 will be something here. Okay, 9, 10. I have to extend this to all the way to 10. 10 is 13.86. 13 point. Let's say this is 14. So 13.86 turn out to be here. Okay. As you can see, once you connect those two, right, then we come up with a regression model. And this is what we call a regression model. Okay, so by plotting those two, okay, we come up with this best fitting line. And best fitting line is what we utilize to analyze, different scenarios or make prediction about for the unknown territory. Okay, so this is first part of analysis that covers positive, strong correlation. Now let's look at another one, right? The other one I created, okay, this one, yeah. I'm gonna make a copy of this. Okay, and then one more time, we're gonna come up with the other. So this is second case with a negative correlation, right? We already analyzed it by drawing the scatter plot. So one more time, let's look at all the detailed calculations really quickly. Okay, for some reason it wasn't covered. Okay, let me copy the whole thing. Okay, go back, copy the data set. Okay, let's do it. And data set is always a starting point for analysis. And let's get to it. Or maybe this time I want you to come up with the table yourself, right? So let's complete a table yourself. Get all the different totals, right? Total of X, total of Y, total of XY. Get all of that. Then we go from there. I give you 5 minutes, right? Complete the table. You can do it in Excel, no problem. XY, that's next one. And then X squared and Y squared. Okay. Now, yeah, try yourself. Make sure you know how to get all these numbers. And then let's get a total for each. Okay.
I have a question.
Definitely. Go ahead.
Is correlation coefficient the same thing as correlation coefficient R?
Yeah, it is the same. Yes. Correlation coefficient R, right? Yeah, we're using symbol R to represent it. So yeah, you're right. Totally.
Okay, thank you.
Very good. All right, so let's complete the table really quickly. All right, so our first one is x times y, so 3 times 12 is 36, right? 4 times 15 is 60, 8 times 6 is 48, 3 times 6 is 18, and 5 times 8 is 40. Then we square each one of these x values. You're gonna get 3 squared 9, 4 squared 16, 8 squared 64, 6 squared 36, 5 squared 25. Okay, now square all the y values, right? So 12 squared is 144, 15 squared is 225, 6 squared 36, 3 squared is 9, 8 squared 64, right? And next step, we just have to sum up each one of the columns. Okay, just let me let Excel do the work for us. Okay, so one more time, I'm gonna copy this table and just gonna modify the numbers there. Put it on another sheet. Okay, here you go. Give me 1 second. Let me just change the number here really quickly and then show you all the detailed numbers. And let me just share with you, I guess. What I did is I just tried to modify the number. I copied the table. And if you modify the number from the original table, you see the number changes too. The result changes. So one table, once you have the right formula implemented in the first table, if you change it, the table will change accordingly. So you don't have to do it one more time, right? So that will be very, yes, here we go. So we come up with the table, and this is all the totals. So total of x, 26, total of y, 44, total of xy is 207, total of x squared is 250, and total of y squared is 478. And that's what we use, right, to calculate R, B0, B1. 3 important elements in the analysis. 26, that's for total of x, 44, total of y, total of xy. It's 207. Total of x squared, let's see, 150, 478. Okay. Yep, 478. Right now, once we have all the numbers, let's get to the first one. Let's calculate the R. One more time, let's copy the formula n times summation of xy minus summation of x times summation of y. Okay, they take a numerator, divide by 2 square root. First one is n times summation x squared minus summation x parentheses square times second square root sample size times summation of y square minus summation of y square. Okay. Now let's plug in the numbers. Again, we have 5 order pairs, so it should be 5. Summation xy is right here, 207. Summation x is 26. Minus summation y is 44. Oh, no, minus multiply. Okay, times 44. I take a numerator and divide by denominator is sample size 5 times summation x squared 150 minus summation x 26 squared. I'll take care of that. Right, put it into the script. parentheses if you want it. And 5 times summation y squared, that's 478 minus summation y 44 square that. Okay, now one more time, let's put into the Excel. Okay, let me copy this, all these different notations from the first sheet. Okay, let's start with the correlation coefficient R. R, right? Exactly what you have in the PowerPoint or the textbook, right? Same thing. So now one more time, open parentheses, 5 times total of x, y is 207 minus total x, 26 times total of y, 44. Take a numerator, divide by denominator, first square root, open parentheses. Then it's sample size 5 times total of x squared. That's 150 minus total of x, 26. Square that, close parentheses. Okay, that will take care of the first square root, second square root. Again, sample size 5 times total of y squared, 478, minus total of y, 44, square that. Okay, close it, close another one. And then you make it slightly bigger so you can look at the formula one more time. Can I do that? No, I can't. Okay, so this is proper input. Once you enter, you get that. So now if you look at it, it's negative, right? If you run it 4 decimal place, and you just make it bigger, smaller, slightly bigger font size. Okay, so it's negative 0.5947. Negative 0.5947. So what this tells us is, first of all, it's negative or indirect correlation, right? Meaning when x increases, y tends to decreases. Okay. And then we also know this value will be the median, right? You see, you have weak, median, and then strong. It fits the median. Absolute value of that is it's fitting the second category. So it's median correlation. So we know that this is median correlation based on the absolute value of this, because it's smaller than absolute value of that. It's greater or equal to 0.25, but it's less than 0.75. And we call this median correlation. So that actually defines this relationship between the two variables. Now we complete the first part of analysis, right? At least we come up with so that's a median indirect correlation among those two, between those two variables. This is what we have. To summarize what we have done so far, right? Now, next thing is find out B0, B1. Again, the formula look lengthy, right? But it's not too bad. You know, once you plug in the right number, just do it slowly at the very beginning. You should be fine, right? Summation y times, copy the formula correctly, plug in the right number. That should do it. Summation y times summation x squared minus summation x times summation xy. Then over n times summation x squared minus summation x parentheses squared. Now again, we extract all the numbers from the prep work That should help us. So 44 summation total of y times total of x squared, that's 150, minus total of x is 26, multiplied by total of xy is 207. Okay, and dividing by the denominator, it's 5 times total of x squared is 150 minus total of x squared, 26 squared. Okay. And one more time, we are going to use the Excel to do the work. Total of y 44 times total of x squared is 150 minus total of x is 26 times total of xy, that turned out to be 207. Okay, that will take out the numerator and divide by denominator. It's sample size 5 times summation x, total of x squared is 150 minus total of x 26. Square that. Okay, that will do it. Here we go. Now this turned out to be 16.46. Once we run it to 2 decimal places, 16.46. Okay. Now again, let's go back. Approximately equal to 16.46. We take out B0, now B1. Copy the formula, n times summation xy minus summation of x times summation of y. Okay. Then n times summation of x squared minus summation x parentheses square. One more time, let's extract all the numbers from the prep work. So 5 times total of xy is 207 minus total of x 26, total of y is 44. Okay, and divide by 5 times total of x squared is 150. Notice that denominator will be the same, right? Minus 26 squared. Okay, now once you have this, then we expect this number to be negative. Why is that? Any idea? Without calculation, we know that it has to be negative. How do we know that? How do we know that? Anybody figure out this? It's from the R, right? Remember, it's indirect, meaning negative. So the slope must be negative. Okay. So from the previous work, we know that we do expect a negative number here. So if we end up with a positive number, that means something's off, right? You should go back, double check the calculation. All right, one more time. Let's compute it. 5 times total of xy, that's 207 minus total of x, 26 times total of y, 44, and dividing by denominator will be 5 times total of x squared is 150 minus total of x is 26 square that as well. Right, one more time, that's proper input and just hit enter. There you got it. Okay, it's negative 1.47. We do expect to have a negative number. Okay. Negative 1.47. Negative 1.47. Okay. Now, once you have B0, B1, okay, both numbers, now we have a regression model. So predicted y value equal to B0 plus B1 times X. Okay. Now plug in B0, B1, and we get a regression model. B0 is 16.46 plus negative 1.47 times X. You combine both sides, you get a predicted y value equals 16.46 plus minus is minus 1.47x. Okay. Now, again, let's make a prediction about something unknown, right? Let's say assuming when x equal to, then pick a known value from the table. We have 3, 4, 8, 6, 5, right? Let's pick now. This time, let's pick 6. So predicted y value when x equals 6 would be 16.46 minus 1.47 times 6. And let's see what that is. One more time, let's rely on the Excel. When x equal to 6, and that should be 16.46 minus, no, 1.47 times 6. Okay. And let's do it. Right, that turned out to be 7.64. That's a correct number. 7.64. Go back here. 7.64. Now let's predict something unknown from the table, right? Look like 9 is not there. Let's try 9 then, right? So basically, once you have the model, you can make prediction of any unknown numbers here. So predicted y value will be 16.46 minus 1.47 times 9. And let's see what that is. Now let's see. So it's 16.46 minus 1.47 times 9. Okay, that turned out to be 3.23. Right, so basically, we move on to unknown territory here and successfully make prediction when x value equal to 9, when independent variable is equal to 9, then the dependent variable, predicted dependent variable y should be 3.23. 3.23. Now, if you want to plot this on a scatter plot, right? We can do that. This time I do it fairly slowly. Okay, so now, one more time. Now we're gonna create a scatter plot and paste the, okay, copy the table really quickly, plot it one more time together with our best fitting line. Okay, so this is the table itself. So we have a 5-order pair. And this is 2-order pair for best fitting line. Okay, we're going to plot that later, but let's just plot this first. Okay, so we have all the way to 9. So we need 9 units. 1, 2, 3, 4, 7, 8. Okay, and on the y value, right? So the maximum turned out to be 15. Similarly, it will be 2, 4, 6, 8, 10, 12, 14, 16. Let's do it. And then plot all the points first. It's 3, 12 goes here. Okay, and 4, 15. Right in the middle here. 4, 15 goes here. Okay, and then A6 goes here. Then we have a 6, 3, 6, 3, it's here. 6 and 3 goes here. And the last order pair is 5, 8. Okay, just like the other one we have, right? So now I'm gonna use a different color to plot our regression model. In something brighter. Okay. So the first order pair is 6, 7.64. 6, 7.64. 6, 4 somewhere. This is 7 here, right? So it's 7.5 here. So now it's slightly above it. So it goes here. Okay. So you get that one. Second one is 9, 3.23. 3 is here, 3.23, slightly above it. Okay, yeah. Now we're gonna connect those two, right? Connect those 2 points. Then extending on both directions. Okay. And then we get a regression model. And here you can label this best fitted line of regression model as 16.46 minus 1.47 times x. And we use this regression model to make any possible prediction needed, right? Yes. Nigora, you have a question?
Yeah, for the Excel project, do you want us to connect the plots as well?
Yes, I'm gonna jump right to that right now. But yeah,
Okay.
very good point. Yeah, I'll show you how to do that in a second. Yeah. All right. And any question from the analysis so far? Or anything puzzles you, you still cannot figure out? Okay, no questions. Very good. So now let's just go to the Excel, right? I'm gonna perform a complete analysis in Excel one more time. Now from this, I'm gonna show you how to get a scatter plot, all those stuff. First of all, in your Excel project, I posted Excel project number 5. It's mainly just on the regression analysis. And let's look at it first. Okay, so you need to know several things, right? First of all, how to construct a scatter plot, and then how to compute R coefficient, correlation coefficient R. And also the last thing is what percentage variation is explained by the X variables. And we utilize this particular term called R squared. Okay, so go back really quickly to the note. So one last thing I did forget to mention is R squared. So right here, we want to find out how good this model is. The measure, how to measure, we use this, how to measure the effectiveness of the model. Remember, sometimes the model is not that effective, effectiveness of the regression model. And we use this term called R squared. So we come up with this regression model, right? But you want to find out how good that is, or how effective this model works. And we're using R squared. Basically, you just square in the R. Okay. So in this case, this R is, we copy that number. It's negative 0.5947, and you square that. So basically, just square this number. And let's see what that is. Okay. And again, we run it to 4 decimal places. So this is negative 0.5947 squared. It becomes positive, right? So R squared is always positive, and this turned out to be 0.3537. You turn into percentage, so this is actually 35.37%. So what this tells us is 35.37% of the variation in the dependent variable y is explained by the regression model, or by the, you could say either way, explained by the independent variable x, or by the regression model. Either either wording is good, right? That tells us only it captures this amount of variation. And if you feel like this is not good enough, that means that this model is not, just doesn't do the work, right? Doesn't work, and then you have to come up with a better model in terms of making prediction. So that's why in this modeling, especially in a simple linear regression model or multiple linear regression model, you always try to come up with a better model. The best model you can possibly have is having the 100%, right? 100% perfect correlation, but that's almost impossible to do in a real life or in the actual context. It doesn't exist perfect relationship, right? So that's how that works. But we try to improve this R square as much as possible to get a best possible model, right? And then if you get a better model, means better prediction, and your outcome will be better off. That's just what it is. Okay. Any question on R square? Okay. And this is important index, right? We utilize to measure the effectiveness of the model. If you look at the first example we went over, that one actually is a lot better off because R square is much bigger. So if you compute R square here, the 0.9566 square that one, you get a much bigger number. And this turned out to be 0.9151. This tells us 91.51% of the variation in the dependent variable is captured or is explained by the independent variable or by this regression model. So this is much better outcome, right? So in terms of comparing model, R square becomes very important tool to compare different models, which one is better off and which one you should use in terms of making a prediction. Okay, so just compare these two examples. The first example gives us much bigger R square, which tells us that this is much better model to predict the independent variable. Okay. All right. So this is the last topic in this particular section in chapter 10, linear regression and correlation. Do you have any general questions about this?
You said you were going to show us the scatter plot.
Yes, I'll do that right now. Okay, so let's jump to the scatter plot and then let's look at a complete analysis. So all of this work is good, right? So in your Excel project, you should also do the same thing, right? Calculate all these different numbers needed to calculate the B0, B1, and then the correlation coefficient R, right? All those are important. For some reason, it's just a stick, should stick. Yeah, good. Okay. So now, first of all, let's start with the scatter plot. So now in terms of completing a scatter plot, you just need to highlight X and Y values without total, right? Do not include a total. Right? Total is not part of scatter plot. Now you go to insert. Now go here, scatter, right? And then you're gonna pick the first option here. And this is the scatter plot. Okay, let me just make it proper size and then I can show you. You can do a lot of things on a scatter plot. First of all, you can pick design on top. I'll make it smaller, you can see that. Okay, let me drag it on the side. And let's look into that more carefully. Drag it on the side. And you can resize it as much as possible, right? That's not a problem. I'll make it a proper size. And on top here, if you click on design, and you'll be able to make pick a design you like, right? Let's say you prefer this design, that's fine, right? There are a lot of sample designs available out there. And also we can modify the scatter plot lot, go to plus. And let's say you want to put in axis titles, right? On the horizontal axis, you want to put X values, right? That's fine. And definitely title is not Y, right? So on the vertical axis, you want to put in the Y values. That's fine. I just show you some of the possible modification you can have here. But no, again, be creative. You can come up with any type of value design you feel like to do. I'm happy with that. Okay. You can put in different colors if you want to, right? No problem. You can fit in different colors for your, so you can just get rid of the filter. Yep. And come up with different font size. You can change a lot of things here if you want to. It's all available there. The next thing important is, again, is you can do a lot of things here, right? Change a little bit from here, like if you want to put in grind line, you can get rid of the grind line, but I think it's better off with that. The grind line there. Okay, that looks better, right? Looks slightly better. Okay. Now, one important thing I want to show you is, let me put in the title maybe. Chart title. Put in correlation of X and Y. To we have a real context, right? Let's say variable is a real, let's say it's stock price from yesterday, and then the Y value will be the stock price of tomorrow. Then we'll be able to put in the actual context, just like the example I mentioned earlier. Those are all possible correlation. Okay. All right, so now we have all of this. Now go back to plus sign. Now I want to show you something really good. Go to trend line here, and you see the direction arrow. The last option, click on it, and follow direction arrow. Open more options. Now feed in a linear model here, and I want you to display a couple of things. Display equation on chart. Also display the R square. Okay, there you go. So those two are pretty important, right? Important thing. First one, I'll make it slightly bigger. Creating different colors to show that. Green letters. Here you go. Now, one more thing I want you to check is, remember we did a calculation for B0, B1. And now from the graph, the B0 turned out to be 2.66. We can run it to 2 decimal place, right? And B1 turned out to be 1.12. And that should matches with our calculation here, 2.66, 1.12, right? And this means you have the right calculation from your end. And the graph here could give you a confirmation. Also the R square, right? So since R is this, so if you want to double check R square. R square should be this number square. And as you can see, if you run it 3 decimal place, it's 0.915. That's also presented on the graph, 0.915. That means your calculation is totally good. Okay. We get a confirmation from this Excel output, from the scatter plot, right? This is also another way of checking your answers, right? Remember, you did all the calculations, but you want to make sure you know you have the right numbers. That's how you do it. Okay. Do you have any question about this? About the scatter plot? How to get that? How to modify the scatter plot? Okay, very good. How to come up with the regression model and the R-square from the scatter plot. Okay, those are very useful. Now, let me just quickly interpret this R-square. Right? So this case is saying that we have 91.5% of the variation in the independent variable. No, in the dependent variable, right? Maybe you want to put y, that's fine. Is explained by the regression model. You can also say that explained by the independent variable. This is what the final conclusion, right? So basically it tells us how effective this model is. So with a 91.5%, you know, effective rate, and that's pretty good, right? If you want to compare to other models, like the other one we have, it's only like about less than 40%. So this is much better model, you know, compared to the other one. And if you want to consider adopt this model, you can definitely adopt it, you know, based on the requirements, you know, from your actual problem. Okay, I think I pretty much cover everything, right? Do you want me to show you anything so to help you complete your project? Let me see. So let's see. Okay, so construct a scatter plot. You know how to do that. So there are two questions here, you know, Excel project. So put your name here and construct a scatter plot. First one has no real context, and you need to calculate B0, B1, right? This symbol should be changed. I modify that in a bit to B0, B1, because in your PowerPoint is using AB, right? But B0, B1 is more standard way of writing a regression model. In a lot of different textbook, usually they're using B0, B1. And calculate the correlation coefficient R, and what percentage variation is explained by the X values or by the independent variable. So you can calculate R square and then state that, right? Write a quick summary of what R square is. And that's pretty much everything you need on the Excel project number 5. And you have until next Monday to complete it. And I guess you could get started, okay, on the 5th project. Okay. All right, still have about 15 minutes. I guess I will put you in a breakout room and I can talk to you individually if you have any concern or issues. Okay, now let's put into the breakout room. Hey.
Professor, I, for some reason, I'm not sure if you remember, I use Google Sheets. So the scatter, all of the like charts don't really let me adjust it at all.
No, you probably want to do it one more time. Just delete it. And let's run through that one more time.
Okay.
Together. Okay, so you just highlight X value, Y values, not the total, right?
Mm-hmm.
Okay, go there. Yeah, exactly. The Google insert and then chart. Very good. And you go to yeah, scroll down a little bit. That's not what we want. Scroll down. Yes, got a chart. Very good. Okay, switch row and columns. Nope. Row 4.
Oh,
Just uncheck on all of them. Uncheck it. Okay. Why it doesn't come out right?
yeah, I have no idea, and it won't let me like move them around.
No. One more time. Do not. Yeah, go back a little bit.
Okay,
Scroll down a
sorry.
little bit.
How do I, oh, edit chart.
Yeah, I try. Good. Now series. On the first series A4 to A12. That's good. X-axis. Add X-axis. Click on add X-axis. See how we can. Yes. It should be A4 to A12. Good. Here you go.
Is this what it's supposed to look like?
Why there's blue and then red. That's we still gotta modify something here. And once you would put this and then delete the other one under series, you see the option A4, A12. No, not that. Yeah, exactly. Remove. Good. Here we go. Now that's your scatter plot.
Okay.
This is perfect one. Okay.
Okay.
Yeah.
So do you mind just like explaining? I'm a little confused because where are,
So you need to specify the x-axis.
all right.
All the x values should be from A4 to A12. And that's why you need to let the expression know, that's what you want. Now, earlier, you did not mention which one is x values, which one are y values.
Oh, in
That's
my
why- Mhm.
4.
Right, in the earlier version of the,
Okay.
and yeah, for some reason, this is not as user-friendly as Excel itself. So you
Yeah.
need to
So what do I label it? I'm sorry.
label relationship of x and y. That's all.
Oh, okay. And then do you mind if I just check one more thing with you?
Definitely.
Okay.
Yep. You want me to check it.
Okay. Well, I did all of this and I'm pretty sure all the numbers are right because I've double checked it a lot.
Okay, very good.
For the whole B thing, does this stuff look like I did it correctly?
Let's find out that from the scatter plot. We can quickly check that. Go to a scatter plot one more time. Okay, now yeah, open the chart options, right? Remember we have options earlier. Yeah, open that. Okay, go to customize. Let's see if it's under customize. Okay, horizontal axis, vertical axis, chart style. No, go to setup. Okay, scroll down a little bit.
That's all it scrolls.
Okay, now maybe go back and then click on all the pairs on the scatter plot. Click on some of them. Click on one of them. Okay. Now scroll down a little bit. Okay. Under trend line, you see trend line? Check that. Okay, good. Scroll down a little bit more. Show R square. Check show R square. Right. Here we go. So you have R square here.
Oh, and good. That's okay. Wait. So
okay.
if R squared here is 0.818, because that's what I got for the last problem.
Last problem. It should be for this problem, no?
Oh.
It should be the same. A11, A1A. Do you get that? Yeah, R square is A1 because if you square 0.9044, you get A1A. That's good. That means R is computed correctly. We just need to find out where's the regression model. Okay, one more time. Click on the chart. Go to setup. Scroll down. Customize. One more time. Click on customize. Now let's go to grind lines and then ticks the last option. Okay, scroll down. No, let's go back to the scatter plot itself. Click on the order pairs. Click on the pair points one more time. Okay, good. And scroll down one more time. Trend line, yeah, show us one more time. Trend line for series. Okay, customize. Scroll down more. Customize labels. click on custom labels, trend line for series 1. Use equation, right? Use equation, very good. Here you go. So the equation is negative, yeah. So now it's come up. So B0 is 108, B1 is 4.14.
Yeah, which I
4.14.
got.
That's what you have. Perfect.
Yeah, but I'm a little confused. R squared is supposed to be 0.818.
Yeah, that's what you have. You see?
So-
yeah.
Oh, so this is supposed to be here.
Yeah, it's supposed to be R squared. That's right.
Okay, and then one last thing. It won't, like, my graph won't let me insert other coordinations. So
No,
it
that's
won't.
fine. You don't have to insert that. Since you have a scatter plot, so Excel already inserted for you. So you don't have to come up with this.
Oh,
Yeah,
okay.
you don't have to insert those. That's
And
fine.
then this looks right too,
That's
right?
Otherwise, your R squared will be off.
Okay, so
Mhm.
hopefully, because it, like, why I was confused about my Excel project 4 is because when I downloaded it in Excel and I thought all of my equations were right, and then I clicked on the document once I saw my grade, and like little blue dashes came up on the first row. I was just confused, like if it adjusts my work because it's Google Sheets or something.
No, it's because you did not put in a formula. Let me show you where your mistake is. That's why I didn't get full credit.
Okay, yeah, that
Not,
would be.
not the other one, because there's no formula set. You're supposed to calculate using formula. But give me 1 second. Let me go to your Excel project number 4. Let me
Okay.
point out where they are.
Thank you so much.
No problem. Okay, just keep loading and see one more time. Okay, it's good. Let's go down to the Excel project. So I think I modified to 100, but you actually, let me point out, this is your Excel project number, because you sent me an email. Okay, let's view great details. Your attempts. Is this project number 4? Yeah, it is. So let me open it. Okay. Yes. All right, here you go. I think for some of them, there's no formula here. You just look it up from the table probably. That's why I give you 90 before, because this wasn't using the formula. But the rest of them was using the formula. See that? The formula. But
I
this
don't
one,
see
you
your
did not use
screen
the
right
formula.
now.
Huh?
I
Oh,
don't see your screen right now.
okay, let me share the screen. Here you go. Then this one, no formula. You just look it up. You're supposed to use formula lambda s bist, and then put in the z-score, right? So it's negative
So
5.
sorry, I'm just gonna share my screen. I think it just didn't, because that's what I put. So
Okay. Yeah, so then that's how you get a result. But when I look at it, you see there's no formula here. That's why I take off 10 points.
okay.
Yeah, but tell me.
Just I think it is an issue with when I download it, because this is my Excel project 4 in my Google Sheets, and when I press on it, it does that. And
But
so
no worry, I think you get a point. I was wondering, yeah, you probably use a
because
formula, but it doesn't show up in my end. So I go
I
back and
think it's
revise.
because
Great already.
I download. Okay, thank you so much. I just don't want trouble. I just don't want like one of like my Excel project 5 to do the same thing. I think it's because I'm downloading it in an Excel form and I
Oh,
use
I see.
Google Sheets. Something must go wrong somewhere.
Okay, no problem. We can always talk and then we can sort it out. Once
Okay,
we
great.
gotta talk about it. Yeah. So no big deal. So I realize you probably did put in a formula, but it just doesn't show on my end. So
Yeah, unfortunately, Google Sheets isn't the same.
Okay, that's fine.
Thank you so much.
That's good. Mhm.
And then I'm kind of going a little slow on the chapters, but it's chapter 6 and then 10, right?
6, 10, and then 7, 8. Then we
Okay.
complete it, right? We have 2 more weeks. And next week we're gonna talk about chapter 7, and then the last week before the final, we're gonna talk about chapter 8.
Okay, great. Thank you so
Okay.
much, Professor.
Okay, no problem there, Neil.
Bye-bye.
All right, bye.
Hi, Professor.
Hey, I was with your other classmates. I just finished with the, so there's a queue. So, all right. So what is your question?
I just started project 5, and I just kind of wanted a little bit of guidance. I think I maybe fell behind a little bit on the lesson today, and
Okay,
I was having some issues.
no problem. So